Alright everybody, for this video I'm going to be drawing a family of function graphs based on parent graphs. Let's start with the old classic x squared parabola. Alright, busy, gotta go. So we're going to start with a simple, I'm going to start from scratch here, nothing prepared beforehand. Start with a simple coordinate plane, x and y axis. Now we could do these graphs using the properties of transformations, but I actually just want to go over some stuff about parabolas first. So we know x squared has a vertex at 0, 0. Let's base the rest of these on the vertices, the vertex. So what would the vertex of this be? It will be -2, 0. So we'd be here. And then since we're sketching, we don't have to be too accurate, but let's go over 1, up 1, and then over 2, up 1, 2, 3, 4. So when you're drawing a parabola, the lead coefficient is 1. You go over 1, up 1 for 1 point, over 2, up 4 for the other. It's like squaring it. And then keep symmetry. Okay, that's more than enough for our first guy. This one, similarly, parabola. Here the vertex is 0, -2, because nothing is happening directly to the x. So at 0, -2, and then here, since the lead coefficient is 3, not 1, we're not going to go over 1, up 1. We're going to go over 1, up 3, because it's a vertical stretch by 3. And instead of over 2, up 4, we would go over 2, up 12. There's not enough space. So let's just finish it off. It's just a sketch. And then last but not least, here we go. Vertex is 3, 0. 1, 2, 3. And now the lead coefficient, we'll deal with the negative last. Actually, let's deal with the negative. The negative is going to make, the negative of the whole thing is going to make a vertical movement, which means our normal parabola is going to be reflected downward, so it's opening down. And the lead coefficient absolute value of 2 means that instead of going over 1, down 1, we're going to go over 1, down 2. Over 1, down 2. And instead of over 2, down 4, over 2, down 8. So over 2, 1, 2, 3, 4, 5, 6, 7, 8. And that would be a pretty accurate graph of the parabola. Okay, we'll come back and talk about the transformations if we got time at the end. But let's go to a family of graphs based on the parent graph of absolute value of x. So here, let's actually talk more directly about transformations. So if we start with the parent graph of absolute value of x, we know that's basically y equals x on the quadrant 1, and y equals -x quadrant 2. So to do this, what are we going to do? Starting inward, moving outward, we've got to multiply by 2. That's going to be a vertical stretch by 2. So this point goes here. Y coordinate of 2 goes to y coordinate of 4. 3 goes to 6. And keep symmetry. It's similar to a parabola in that sense. But let's not finish it off, because then we got to reflect over the reflect over the x-axis to make a vertical movement. So this goes here, this goes here, this goes here, etc. And then finally we go down 3, shift down 3. So this quote-unquote vertex goes down 3. This point goes 1, 2, 3. And so what we have is the V shape like this. So if we start here and then kind of go at a slope of 2 and -2, that should do the trick. Good. Here, Now we've got shifted left 5, up 4. Well, first, left 5, right? It's like the quote-unquote vertex is at x equals -5. 1, 2, 3, 4, 5. Now we've got a vertical stretch of 3. So instead of going up, over 1, up 1, over 1, up 1, we're going to go over 1, up 3. 1, 2, 3. Because it's a vertical stretch of 3. Okay, so we kind of got this shape. But then we're going to translate or shift up 4. So let's not finish it off. Let's shift up. 1, 2, 3, 4. 1, 2, 3, 4. So here's the beginning. It's going over 1, up 3 because of the vertical stretch of 3. Something like that. And last but not least, this is technically a, starting with absolute value of x, a horizontal stretch or shrink because it's affecting only x. And it's actually a horizontal shrink because we remember when you affect x, you got to think in reverse. So even though we're multiplying by 3, we're getting smaller. It's going to be a factor of 1/3. So instead of this, we're going to shift horizontally. Let's look at one point at a time. Instead of the point 3, 3 on the original parent graph, the x coordinate is going to be multiplied by 1/3 and become 1, 3. -3, +3 is going to become -1, +3. And if we want to down here, for instance, 1, 1 would become 1/3, 1. But basically, you're going to end up with something that has the slope of 3 and the slope of -3 here. So we've got f of x, g of x, h of x. By the way, here is a case where, this is our answers, by the way. So I'll just do a short explanation. By the way, this is one case where the horizontal shrink of 3, 1/3 rather, sorry, horizontal shrink of 1/3 is actually the same as a vertical stretch by a factor of 3. Because absolute value of 3, you can just pull it out. So this is a case where actually the horizontal shrink is exactly the same as the vertical stretch. What else do I want to go over? Oh, how about this, real quick? A word about this. So let's say we started with j of x equals -2x minus 3. What would that look like if it was just a normal line? That would look like something like a y-intercept of -3 and a slope of -2, down 2 over 1, down 2 over 1. This would be this blue line. So how do we get from this blue line to this? Well, j of absolute value of x, absolute value transformations. That's exactly what this f is. And so how do we go from the blue to this? Well, we follow the rule. Everything with a positive x value, you keep the same. Good. Everything with a negative x value, you kind of get rid of it, disregard it. And then to replace it, you take the original points with a positive x value and reflect them over. Hence, that's f. Let's leave it at that for today. You know, we all got things to do. So, without further ado, I'll remind you to keep asking questions. And as always, go blue.